You might remember that we were in a lesson called Find a Place to Live. And finding a place to live has to do with the size of the place to live. Take a look at this table that was given to us that was in an example in that lesson. It goes all the way from 664 square feet, growing all the way to as much as 1,697 feet. And how much does it cost to live in these places? Well, this is $995 for the 664 square foot place, 1,697 feet, and it's going to cost you $1,995. Well, I don't know about you, but I look at a table like this and it's just begging to be plotted. Here I have Desmos up, and we're going to click on this plus sign right here, and when we do that, we get all these choices of functions that we can use. We're going to create a table. Now, when I click table, it automatically comes up with X's and Y's since we're plotting in 2 dimensions, and we have to type in all this stuff for the X's and their corresponding Y's. So when X is 664 for the first one and 735 for the next one, there's all the X's. And that's all the square footages that were listed on that table. Now we're going to put in the corresponding prices. 995, 1045, and there we have all the prices. So if you look carefully, we have all the numbers from the table that was in the example loaded into Desmos. Now, what does that mean? Well, I think it means that we've got points. That's what this little circle, this green circle that has the dots on it says, that we've plotted these. So we look over to the right and there it is. Well, no, it's not, because we're only looking from -10 to 10 from left to right, and we're only looking from -10 to 10 from down to up. According to this table here, we are no farther to the left than 664 and no farther to the right than 1,697. And we don't go any further below 995 and any higher than 1,995. So let's fix that. You see this tool up here? We can do the graph settings, and we can actually say, what do I want to see in the window? So I'm going to go ahead and just put a number that's just to the left of 664. How about 650? And then let's put to the right then something to the right of 650. Well, how about 1,700? And that's going to encase our 1,697. Now, how about for the y-axis? We're really not seeing anything yet, but for the y-axis, we need to go no lower than, how about 950? And the highest that we're going to go on the y-axis is going to be 2,000, let's just say. Oh, and look at that. As soon as we put in that 2,000 and plugged it in, now we see all the data that we were talking about here. Well, let's take a look at this one right here and just click on it. 1,133 matches up to a price of $12.95. Is that true? Well, 1,133, 1,295. And there that is. Let's do one more point and then we're going to move forward here. 1,150 gives me 1,595. So it looks like I did get this all into the chart just fine. $1,150 and $1,595 is the price of that. And so that's how that is. The next place that we're going to go is that we're going to teach you how to use this information and create something called a LRL, which is the least squares residual line. And this is also called a line of regression. You remember that the equation of a line is y equals mx plus b. Wouldn't it be nice if we could come up with a y equals mx plus b that is closest to all of these points? In other words, creating a line of best fit. Well, that's what an LRL is. And here's how it's done. So we see that we have everything plotted in x1 and y1s, and we want to get our y equals mx plus b that matches all that stuff. So it's as simple as this. You just type y1, and you say, you want to say equals, but it's not going to be equals. We're going to use the tilde symbol, which is just to the left of your number 1. And so if you hold down shift and hit tilde, you get that little squiggle line there, okay? Then we can say m, because we want the slope, and we want x1, because we're using that list again. And look at that, we're already starting to see a line, but it's not exactly where it ought to be, because we need to know what that is. But what we're doing is we're asking Desmos to use its programming to show us these things. If we just say, I'm just asking for y equals mx plus b, so I'm just going to put a b there, and we're done. Now look at what this says. This says that m is, what is m? M is the slope. So the slope is going to be equal to 0.906157. And what is b? Well, b is the y-intercept. It's where the line crosses the y-axis. Well, it crosses no lower than 403.087. So if we went all the way to the left of where we are, right now we're looking at somewhere, around 600 or so, or 500 on the chart there. If we went all the way to the left to 0, we'd still be at a height of 403, and that's what that means. So here's our line of best fit, and or an LRL. Now there's another thing that we wanted to talk to you about, and it's called the correlation coefficient. And that's with the idea of the strength of the line and how it relates to all the points that we have. You see, that's this number right here, r. We actually calculate an r squared, and that's the squaring part of the least squares residual line stuff. It's talking about the distance that these points are vertically from this line of best fit. If we added up positives and negatives of these distances that these are, if we're below the line, then that's a negative number. If we're above the line, that's a positive number. If we add them all up, and actually we're adding all the squares, and then we're taking the square root of the sum, we get this number. And the way that this is said is that the strength of the relationship between the line of best fit and the points goes anywhere from -1 to 1. That's what this correlation coefficient is indicating. If you went -1 or somewhere between -1 and maybe -0.8, then you have a strong, what's called a negative correlation, meaning that this line would be drawn with a negative slope. But we have a positive slope, so we're at positive 0.96. So that's really good. At 0.96, that's super strong. And you can see that by how close the line is to those points. So that's called the correlation coefficient. That's what R is representing, and it is the strength of how good of a fit that line is. And later in the book, we actually see a part here that says what would be expected for an 880 square foot apartment. So if we went ahead and just said 880 square feet, we're looking for a number that's going to be in here. Now, according to this chart, just guessing, 880 is a little bit more than 872, and it's less than 903. And so we're going to find a number, we hope, between 1205 and 1245. I'm going to just put something down here, and let's just go ahead and plot y equals, and we're going to say this m, 0.906157, and we're going to say times 880, because x is 880 square feet. And then we're going to add to it 403.87. And let's see what we get. Now when we hit return, look at this number right here. 1201.3 is what that comes out to. 1201, that means $1,201.29 is going to be what we're charged. Well, let's see how good that is. For 800, we just came up with a number that was lower than, so we're going, hey, if we wanted to get that 880 square foot home in that area, we better go for it, because we can get about $4 less per month on the square footage. And so that shows you that this chart is a good one, and gives you a good estimate of what we're doing.